problems. Yeah. Okay, so the sun is approximately 93 million miles from the Earth. How can that distance be expressed using scientific notation? So 93 million how do we express that in scientific notation? So our possible answers are 97, 930 times 10. And so those are our possible answers. Now we know from our earlier lessons that scientific notation, the decimal has to be behind the first digit, okay? So we know immediately that this one and that one cannot be the answer. So it's a choice between these two, okay? And we also remember that if you have a number and there is no decimal listed, then the decimal is actually here, okay? So we have to move this decimal, 1, 2, 3, 4, 5, 6, 7. We move it here, and because we went this way, it's going to be a positive number. So our answer then would be B. Because 9.3 times, that's 10 million, will give us 93 million, okay? 9.3 times this, which is a very small number, will not give us 93 million. So that will be our answer there. Questions on that? Okay. All right, let's go into number 2. All right. Okay, so Joanne is buying food for a party. She purchases 6 pizzas for $9.75. 6 pizzas, $9.75. She purchases 4 salads for $3.50. And she purchases 5 bottles of soda. She purchased those for $1.25 each. Okay, let's see. And so they want to know what is the total cost for all the food and drinks. Our possible answers are A, $14.50, B, which is $15, C, which is $58.50, and D, which is $78.75. Okay? All right, so we then have to figure out how much each one of these are going to cost. So 6 pizzas at $99.75. $9.75 times 6. 6 times 5 is 30. 0, carry 3. 6 times 7 is 42. Plus 3 is 5. Carry 4. 6 times 9 is 54. Plus 4 is 58. We have 2 decimals, so we know that this is 58.50 just for the pizzas. So we can immediately, if we wanted to, eliminate everything. We know it has to be more than that. It has to be more than that. 58.50 is just the cost of the pizza. They want the cost of everything. So we're already at $58.50 just for the pizza. So we know this can't be the answer either. So our answer then is $78.75. But you could then figure that out the long way as well, because again, the KC is an untimed test. So if you wanted to do that, 4 times 0 is 0, 4 times 5 is 20, 0, carry your 2, it would be $14. Then we could do $1.25 times 5. That's 5 times 5 is 25, carry your 2. 5 times 2 is 10, plus 2, 12, $6.25. give us 75, 78, 75. So you could have figured it out as well. So if you didn't realize right away that these were too small, you could have gone and figured it out. But you notice, if you just look at the pizzas, right, you know that these two have to be wrong, and we still have to add in these other ones. So we can immediately cross that out. On tests like the Casey, since it's untimed, feel free to go ahead and write out all the problems. But on tests like the HiSET or the GED or the SAT, you have a time limit. So if you can figure out ahead of time what the wrong answers are, then you go right to the right answer. Okay. Any questions on this? All right. Let's do the next one. Okay, we have 2/3 divided by 1/4. Our possible answers, this is number 3. Our possible answers are A, which is 2/12, B, which is 1/6, C, which is 11/12, D, which is 2 2/3. Okay. When you divide fractions, you invert or take the reciprocal of the second number and multiply. Okay. So if I were to look at a number, let's say 1 divided by 3, that's the same as dividing by 3. Okay. So multiplying by the 1/3 is the same as dividing by 3 over 1. So whenever you are dividing by a fraction, you're essentially multiplying by its reciprocal. And that makes sense. For instance, if you were to, if you had 4 divided by 2, that's the same as 4 divided by 2 over 1, which is the same as 4 times 1/2. Because in each of these, you'll get the same answer, which is 2. So whenever, if you don't remember which one to flip, all you really have to do is just look at divide by 2. And then you'll know that that's the same as multiplying by 1/2. Okay, so going on, we end up with 2 times 4 is equal to 8. 3 times 1 is equal to 3. All right, we look at our answers, and you see here that our numerator, our top number, is larger than our denominator, our bottom number. So we know automatically it can't be this one, or that one, right? Because this one, the numerator is smaller, the top number is smaller, this one, the top number is smaller, this one, the top number is smaller. So it has to be this one, but let's double check. I like doing like Aaron Rodgers, just double check. Sorry. Commercial for State Farm. All right, so 3 goes into 8 2 times. 6, carry your 2, that'll give us 2 2/3. So our answer is D. But again, if you look here, you know that if you have a higher number as your numerator on top, then you know that these can't be those answers. So you're left with that one, okay? All right, let's do the next one. All right, so Felix has an hour and a half to watch TV. Has an hour and a half to watch TV. Okay? If he spends 2/3 of his time, he spends 2/3 of his time watching a football game, how much time will he have left to watch another show? How much time does he have left over? And our answers are A, which is 1/3 of an hour, B, is equal to 1/2 an hour. C is equal to 5/6 of an hour. And D is equal to 1 hour. Okay. So he has 1 hour and a half, which is 1.5. Okay? All right, so he has an hour and a half to watch TV, and he spends 2/3 of that watching football. So we have to multiply 1.5 times 2/3. Okay? We have to turn this from a mixed number to an improper fraction, and we do that by multiplying the denominator, the bottom number, times the front number, the whole number, 2 times 1, and then we add the numerator. So that'll be 3/2 times 2/3. Okay, 3/2 times 2/3. You could cross cancel it, or you just multiply across. We end up with 6/6. And we remember from our discussion of fractions that any number over itself is equal to 1. So he had 1 hour, 1.5 hours to watch TV. He spent 2/3 of that watching football, and that is equal to an hour. And they want to know how much time he has left. So if he had 1.5 hours and he spent 1 hour, the only time he has left is a half hour. So our answer then is B. Okay, any question on that? All right. Let us move on. Okay. All right. The Tigers, my favorite baseball team, Detroit Tigers. No offense, Dodgers. Oh, my second favorite team. Hopefully they won't meet in the World Series this year, then I'll be sad. Oh, thanks. All right, the Tigers have won 75% of their baseball games. They won 75% of baseball games. Okay. How many of the remaining 32 games, 32 games remaining, so how many of their remaining 32 games can they lose and still maintain their winning percentage? Okay, how many can they lose? Okay, so we're looking at lose, all right? So 75%, they won already 75%. In order to keep that 75%, they'd have to win 75% of these, right? Does that make sense? So if they have 32 games left and they want to maintain their 75%, they have to still get 75%. If they get lower than 75%, then their overall average won't be 75%. So they have to get 75%. So let's figure out what 75% of 32 is. So we do 32 times 75%, and again, 75%, we can write as 0.75 or 75 over 100, okay? We're gonna write this as 0.75, okay? 5 times 2 is 0, that means 10, carry a 1, that'll be 16. 7 times 2 is, well, we skip a space first. 7 times 2 is 14. Carry 1, that'll give us 22, right? 0, 0, carry 1, 2, 3, 4, 24. 1, 2 decimal places. So to keep their 75%, they have to win at least 24 games, all right? So here are the possible answers. A is 8, B is 16, C is 24, D is 25. Okay? So we've done all this, you see 24, and immediately you look over at the answer and go, oh, 24, yay! But that's not what they asked. They said how many can they lose, right, of their 32 games. They need to win 24 which means they can only lose 32 minus 24, which will give us 8. So your answer will be this one. When you take tests like the KC or the HiSET or the GED or the SAT, they usually throw in an answer that is close to your half answer. Like you're halfway done, they usually throw that in there because they know that you can't help but peek over at the answer and you'll be distracting. Oh, 24, 24, and you'll circle it and go on. Even though you really got the problem right, you marked it wrong because you weren't done. So you have to be careful to look at the wording on the question. They wanted to know how many they could lose, not how many could they win. Okay, so definitely make sure you read the questions. Okay, any questions on this? All right, so let's continue on. All right, let's go to the next one. Approximately 4% of automotive parts in the factory are defective. So 4% are defective. Okay. If the factory creates 27,000 parts in a month, how many will be defective? So we need to know what 4% of 27,000 is. So we have to turn 4% into a decimal, and that's going to be 0.04. It is not 0.4, because 0.4 is 40%, right? So if it's 4, you have to move it 2 places, so you have to remember that. Which is also equal to 4 over 100. So we simply multiply 27,000 times 0.04. Our possible answers are A is 4, B is 108, C is 1,000, C is 1,008, D is 1,080. Okay? And so we have to multiply this out. 4 times 0 is 0, 4 times 0 is 0, 4 times 0 is 0, 4 times 7 is 28, carrier 2, 4 times 2 is 8, plus 2 is 10. Okay, and then you can do the zeros here again, but we don't really need to. But let's do it anyway, just for good habit. So it'll be 0, 0, 0, 0, 0. We add 8, 0, 0, 0. 2 numbers behind the decimal. 1080, which is answer D. Okay. And we'll do another percent one. Any questions on this? We'll do another percent one.
Those 2 questions you just I got them wrong on the GED.
Oh, see? Now you know.
I couldn't get them at all.
Now you know. See? You come to my lesson every Monday and Wednesday. Well, not next Monday, because I'll be in the meeting, but normally every Monday and Wednesday. Monday or Wednesday, because it's the same lesson. All right, the price of gasoline in June is 20% higher than the price of gasoline in January. If the price in January is $1.50 per gallon, what will the price in June be? Okay, so gasoline in June is 20% higher than the price in January. If the price in January is $1.50 per gallon, you sing and jump for joy because it's not that now. Oh, I'm sorry. I wish it was $1.50. My God, I remember those days. All right, sorry. If the price in January is $1.50 per gallon, what will the price be in June? The possible answers are A is $1.20, B is $1.70, C is $1.85, D is $1.80. I'm sorry, $1.75. B is $1.80. Okay. So we know right off the bat that it cannot be $1.20, right? Because the price in June is higher. So we know off the bat that this one cannot be the case. All right. So as soon as you know something's not the case, just wipe it out in your mind. And I think in the case you can write in the book, just get rid of it so that you weren't tempted to even look at it. So we have to do 20% of $1.50. So we do $1.50 times 0.20, because again, 20% is equal to 0.20. It's also equal to 20 over 100. Okay? So multiply 0 times 0 is 0, 0 times 5 is 0, 0 times 1 is 0. 2 times 0 is 0, we skip space. 2 times 5 is 10, carry a 1. 2 times 1 is 1 plus 1. That's 3. 0, 0, 0, 3. There are 4 numbers behind the decimal. 1, 2, 3, 4. That means we have to have 1, 2, 3, 4 numbers behind our decimal. So 30 cents is how much higher it's going to be. Okay, but they didn't ask us how much. They didn't ask us how much higher. They want to know what the price is going to be. Well, the price is going to be $1.80 because we started with $1.50 and then we added 30, and that gave us $1.80. So the answer will be D. Any questions? Right. Okay, so we're going to switch a bit over to the next type of question. I'm going to deal with some exponents. All right. So as a reminder, you have exponents. You have a to the m times a to the n, meaning the bases are the same. We add the exponents. If you have a to the m divided by a to the n, the bases are the same, you subtract the exponents. If you have a to the m and you raise the whole thing to the power of n, it's going to be a to the m times n. If you have a to the negative m, that's the same as 1 over a to the m. If it's negative in the numerator, it becomes positive in the denominator. If you have 1 over a to the negative m, that's going to be a to the positive m. If it's negative in the denominator, the bottom number, then it becomes positive, and you move it up to the numerator, because this is the same as this, which is the same as that. Okay. So that's just a quick recall. So let's do some problems. Okay, we have 3 to the, we have 3 to the second power divided by 3 to, 3 to the third power divided by 3 to the negative 2. Our possible answers are A is 3 to the negative 6, B is 3 to the negative 1.5, C is 3, D is 3 to the 5th. Okay? All right? So again, we have this divided by that, which means we have to subtract the two exponents. That's going to be 3 to the 3 minus whatever this is, which is negative 2. That would not be 3 to the 3 minus 2, because this is a negative number. We still have to subtract it even though it's a negative number. Okay, so that's not the right way. So we have to do this. All right? We know that subtracting a negative is the same as adding a positive. That's going to be 3 plus positive 2, which would give us 3 to the 5th. So the answer then would be D. Okay? So these you have to know. You have to know how those work when you have the same value. And if you ever get confused, my favorite thing to do is look at number 2. All right? So if I have 2 to the 3, which is the same as 2 times 2 times 2, and 2 to the 2, which is the same as 2 times 2, if I multiply those together, that'll be 2 to the 3 times 2 to the 2 is the same as 2 times 2 times 2, which is this one, times 2 times 2, which is that one, and that gives me 2 to the 5th, right? So if I had 3 of them and 2 of them, I end up with 5 of them. So if you go back to 2's, it's kind of easy to remember these, okay? All right. Any questions on that one? All right, let's do another one. A little out of order. Number 12, which is 5 to the 2 raised to the 3. Okay, and our possible answers are 5, B, 5 to the 5, C, 5 to the 6, and D, 5 to the 15. We know from our rule over here, raising a power to a power means you multiply, so this has to be 5 to the 6. Okay. Questions about that?
How do you do it? You just multiply the powers?
Yeah, you multiply the powers. The rule is if you raise a power to a power, you just multiply the powers. If you're multiplying two bases with the same power, you add the powers. Okay. All right. Okay, so now we're going to look at some fractions, or a fraction, I should say. Yep.
Oh, only this. That's around there.
Oh, you sure? Talk about the erasing pen, right? Love knowledge. Take it on in. Sorry about the
Wait,
handwriting.
what was it? M minus N on the second one?
This one, this is minus, yes, that's correct. M minus N, that's correct. This is M to the N equals A to M times N.
Oh, that's A, M to the N.
This should be an N. That's a turbo N, right? That is why I'm here. To stand, this is A to the negative M equals 1 over A to the positive M.
What is the bottom is negative M?
Yeah, A to the negative M is equal to A to the M. A to the positive M. This is the negative. 1 over A to the negative M is equal to A to the positive M.
All right, thank you.
So the negative makes it flip into the other side. If it's in the denominator, it moves to the numerator and becomes positive. If it's in the numerator,
This is a reciprocal, pretty much.
yeah, kind of. Okay, so let's do a fraction. We have 4/15 plus 2 over 27. Here are our possible answers. Possible answers are 6 over 135, B, 6 over 42, C, 42 over 135, and D, 46 over 135. Okay? So in order to add fractions, we need to have a common denominator. Okay? So if we were to look, we would say, well, we know that 15 and 27 don't go into 42, right? Then the answer might reduce to that, but for now we know that it doesn't go into that. So let's see if 135, since all the other three answers have 135, let's see if that's a common denominator. It may or may not be. It may be something else that reduces to that. But we don't know, but since we don't know, we might as well go with one of the ones we have, right? So let's start with 135. Well, 15, does 15 go into 135? Okay, yes it does. It goes in there how many times? Well, we know 15 times 10 will give us 150. So it'll probably be a little bit less, so let's try 9. 9 times 5 is 45, carry your 4. 9 times 1 is 9 plus 4 is 13. So we know it's 9, all right? Well, we know 9 times 15, so we are going to give ourselves common denominator of 135. But before we do that, let's check to see if 27 goes into 135. obviously, the only time 7 is going to go to anything with a 5 is if we multiply it by a 5, right? So, like 7 times 5 will give us 35. So we'll see if that works. We'll do set 27 times 5. Because we did 27 times 1, we know we'd end up with a 7. 27 times 2, we know we'd end up with a 4 at the end. All you have to do is just look at each number when you multiply by 7. The only time we're going to get a 5 is if we multiply by a 5. Okay? That makes sense? Yep. All right, so 5 times 7 is 35. Carry a 3. 5 times 2 is 10, plus 3 is 135. Lo and behold, we have our common denominator. 7 equals something over 135. This is times 5. This one was times 9. Okay, whenever you do the bottom, you have to do the top. 2 times 5 will give us 10. Whenever you do the bottom, we have to do the top. 4 times 9 will give us 36. Okay, now we can add them because they have a common denominator. We know the denominator will stay the same. So we have 36 plus 10, which would give us 46. So our answer will be B. Okay?
So since 9 was times 15, you multiply 9 into 4.
Yeah, whenever I multiply 15 by to get 135, I have to do the same to the top. Whenever I do the denominator, I must also do to the numerator. Whenever you get an equivalent fraction. Because essentially, this is just multiplying by a number over itself, which is 1. You're multiplying by a number over itself, which is 1. That's why you're doing that. So I haven't really changed the value of the fraction. All I did was change it so that I could work with it. Because I'm really just multiplying by 1. Okay? Okay. Any questions on this? All right, so let us talk about mean, median, and mode. And let's just do a quick review of those guys. Mean is the average, and we get that by adding all the numbers and then dividing by how many numbers we have. The mode is the number that occurs most often. Sometimes you can have more than one mode. If it's one mode, it's unimodal. You won't have to know that till you get to like statistics. If it's 2 modes, it's bimodal. 3 modes, trimodal. It's whatever occurs most often. So sometimes you'll have more than one number that occurs most often, okay? And then the median is the middle number. So for the median, you put them in order from smallest to largest, and you pick out the middle number, okay? Now sometimes what happens is you have 2 numbers in the middle. So if I had something like this, 20, 30, 40, 50, 30, let's say 60, and let's say 70, just for the sake of it. These two, I have 2 middle numbers. I have 2 above and 2 below. In that instance, for the median, we have to take the average of these 2, or the mean of these 2. If it's an odd number, you just pick the one that's dead center. If it's an even number, you have 2 in the middle, you take the average of those 2. Okay, so that's just our review on that. So let us look at question number 15. Everybody have this? Clear on this? We'll look at question number 15. All right, question number 15, which is, Janet has taken 4 tests in French class, scoring 62, 85, 90, and 75. So she scored 62, 85, 90, and 75. So they want to know what her median score is. So again, for the median, we have to put them in order, from smallest to largest. So we'll reorder this. So it'll be 62, it'll be 75, 85, and 90. All right, so there's no one middle number. We have these two together, which are our middle number, all right? If there are two numbers, then we have to take their average. So we have to add 85 plus 7, 85 plus 75, 5 plus 5 is 10, carry a 1, 7 plus 8 is 15, plus 1 is 160. We have two numbers, so we have to divide that by 2. Okay, 16, 2 doesn't go into 1, 2 does go into 16. 8 times, bring down our 0, 2 goes into 0, 0 times. So 80. So our possible choices were, sorry, I didn't write those down. We had 78, 80, 87.5, and 90. So in this instance, our answer would be 80. Okay? Any questions on median? Okay, we'll do one more. We'll start with the graph stuff next week. So we'll do this last one. And this last one has to do with mode. Okay? All right? So for mode, all right, so 5 students are competing to win a prize for selling the most chocolate bars. Sorry, I love chocolate. Chocolate. I'm watering as I say the word. Okay, so here are the students. One student sold 32 bars of chocolate. Another one sold 15 bars of chocolate. Another one sold 27 bars of chocolate. Another one sold 32 bars of chocolate. And the last one sold 15 bars of chocolate. What is the mode? Remember, the mode is the most frequently occurring, the one that occurs the most. Okay? So in this instance, we have two numbers that occur twice. So our mode then would be 15 and 32. Okay? In the answer, they gave us 15, B 27, C 32, and D 15 and 32. So D would be our answer, but if you notice, they kind of threw these two in here to kind of confuse you. So you might go, well, 15 or 32. Okay, I'll just pick one of them. That's wrong. It's 15 and 32 because this is what we call bimodal. It has two different modes. Any questions?